Okay, so this is some extra problem solving. It never hurts to do some extra problem solving. So we're doing some more problems, and these also incorporate angles of elevation and depression. So what we did earlier today. So, you've gotten a chance to try a few on your own. Now let's try a few more together, and then we can see how you do. So, example number 1. A 56-meter wire supporting a TV tower, 45 meters tall, joins the top of the tower to an anchor point on the ground. So we have a picture there telling us what's going on. What is the angle theta to the nearest degree? So we're looking at angle theta here, okay, that the wire makes with the ground. So that would be our angle of elevation, okay. Now we are going to follow our procedures. This is our angle of interest, the theta. So 56 is across from the right angle, so that would be our hypotenuse. And 45 is opposite our angle of interest. The side we don't know, we don't care about, is our adjacent. So now we've labeled our sides, first step. Now we're going to circle what we know. So we know opposite and hypotenuse. So thinking about SOH CAH TOA, opposite and hypotenuse means that we are using sine. Okay, so what that means is sine theta equals opposite over hypotenuse. So we're going to substitute in what we know, which is 45 over 56. And we're going to get from that 45 divided by 56, 0.80357, so 36. Okay, remember 4 digits, just for good measure. Now we're going to use the second function, sine -1, 0.8036. And when we put that in our calculators, it tells us that theta is 53 degrees. Okay, so don't let the words freak you out. It's just a matter of interpreting, right? Once you draw your triangle, and then you can go through those same procedures. Label, circle, choose, solve. Okay, let's look at another example. Example number 2. Okay, so I don't know why I have this weird thing here. I have a weird table there that I think was carried over from something else. So we're going to ignore that, okay? I think it just was a carryover piece. So ignore all of this, okay? We've got a picture of a building there. I'm going to redraw it. So we've got our building, and we have a ladder resting on its side. Now, the ladder resting on the side of the building forms an angle of 44 degrees with the ground. So it tells us that it forms an angle with the ground. So the ground is, and let's just move this up a little bit. The ground is at the bottom there, okay? So we've got this angle here is 44 degrees because it formed that angle with the ground. If the ladder is touching the building at a height of 8 meters, so this height here is 8 meters from the ground, how long is the ladder? So we want to know the length of the ladder. So looking at that, let's do our labeling. So our angle of interest is the 44 degrees, right? So that's what we're looking for from. And this is our hypotenuse. And our 8 meters is our opposite. And if we wanted to know how far away from the building it was, that would be our adjacent. Okay, now we'll circle what we know. We know our opposite, and we're looking for our hypotenuse. So we're looking for a side, but let's think about SOH CAH TOA. SOH CAH TOA. Opposite and hypotenuse tells us we're going to use sine. So let's set this up. Sine theta equals opposite over hypotenuse. Sine of 44 degrees, because that's our theta, is equal to 8 over x. Okay, now we're going to put that over 1, and we are going to cross multiply and divide. Okay, so that means that x is going to equal 8 times 1 divided by sine of 44 degrees. Okay, I'm going to do a little U-turn there. So that will be x is equal to, let's figure out what sine of 44 is. Sine 44 is, so we have 8 divided by sine of 44 is 0.6947. So 8 divided by 0.6947 equals 11.5. And we know it's meters because that's how tall it was leaning against the wall. We always keep the same units. Okay? So just applying the same information there. Okay. We have another example here. A tree is 5.9 meters high, and it casts a shadow along the ground. So let's draw our picture. I like drawing my picture. So we've got a tree, okay, and it has a shadow. Ooh. Now the shadow, or the tree, is 5.9 meters, and the sun's rays, so that means we have a sun over here, right? Like we've got our sun up here casting rays. Let's make it a nice pretty sun. Won't be red, it'll be yellow. Okay, casting a shadow. And it is gonna have an angle of 60 degrees with the ground. Okay, so that means it says very clearly it makes an angle of 60 degrees with the ground. So that's going to be in here. So that's 60 degrees. Okay, and it wants to know how long, how long is the shadow of the tree rounded to the nearest tenths? So if it's looking for the shadow, it wants to know this one right here. So it wants to know the length of the shadow. So let's do our labeling. This is my hypotenuse because it's across from the right angle. Okay, and once again, I know my opposite. Okay, and then what I'm looking for, x, is my adjacent. So if I circle what I know, it's opposite. What I'm looking for is adjacent. So think about my SOH CAH TOA. And if you want to draw your triangle without the tree in there and all the others, the sun, you can just draw a freestanding triangle, that's fine. So I need opposite and adjacent, so I'm going to use tan. So tan of 60 degrees equals opposite over adjacent. So tan of 60 equals, I know my opposite, 5.9 over x. Remember, I can put this over 1, and then I'm going to cross multiply and divide. So when I do that, I get x is equal to 5.9 times 1 divided by tan of 60 degrees. Okay, and we're going to sweep up here. Tan of 60 is 1.3 something. X is equal to, this will be 5.9 times 1.732. So we'll multiply that, and we get x is equal to 10.21 meters. Now it says round to the nearest tenth, so it'll be 10.2 meters. Okay, because it says nearest tenth. Okay, so that's, it's just problem solve, read the problem, and find the way to solve it. It's exactly the same as we do when we just have triangles. Now, before we start the next set of examples, we're going to review what we know we're talking about with angles of elevation and depression. We talked about this morning. angle of elevation is the angle formed between the horizontal and looking up, and the line of sight when looking up. So it's right here. And the angle of depression is the angle formed between the horizontal and the line of sight when looking down. So it's still with the horizontal. So it just helps you identify, don't let it freak you out. It just helps you identify where to put that angle. Okay, so let's take a look here. Girl is flying a kite. There's a boy standing 12.5 meters away from her. So let's label this in what we know. Okay, so the boy and the girl are 12.5 meters apart, and he's directly underneath the kite. Now she's used 33 meters of string, so that's how long the kite string is, and it wants to know what the angle of elevation is. So what is the angle of elevation? Is the angle looking up. So what is this angle in here? Okay, so once we figure out where everything is, then we're just going to do our work in terms of labeling. So we know that this is our hypotenuse. This is our side right next door, so it's adjacent, and this would be the opposite. We circle what we know. We know our hypotenuse, and we know our adjacent. So we're using adjacent and hypotenuse. So we're using CAH, right? So we're using cos. So cos of theta equals adjacent over hypotenuse, which is 12.5 over 33. So we get 12.5 divided by 33, which is equal to 0.3787, and it repeats, 87 repeats. So this is where, to find theta, I use my cos -1. So use your second function button on your calculator, 3787, and so on. And when I put that in, second function cos, 0.3787, etc. And I get my theta is, and it's to the nearest degree, it's 67.7 degrees, so that would be 68 degrees would be my angle of elevation. So again, all that angle of elevation and depression allows us to do is it tells us where to put the angle. Okay, let's do another one. An air traffic controller is standing in a tower looking down at an airplane on the runway. If he is 18 meters above the ground and the airplane is 68 meters from the base of the tower, what is the angle of depression? So, thinking about this will be our angle of depression, right? Okay, because he's looking down at that airplane. He's 18 meters above the ground, so 18 meters. He must not be at the top of the tower. He's halfway up the tower standing there. Okay, but he's 18 meters up. And the airplane is 68 meters from the base of the tower. So that's that big long length. So from that, this is our angle of interest, right? Which is our angle of depression. So that's where we're looking from. We're going to label our triangle. Well, this would be our hypotenuse. This would be my opposite, and this would be my adjacent. Let's circle what we know. We know our adjacent, we know our opposite. So we're going to use tan, because it's TOA, right? So let's figure it out. Tan theta is equal to opposite over adjacent. Opposite is 18, adjacent is 68. So tan theta equals 18 divided by 68, which is 0.2647. So then I'm going to use my second function button to do tan -1 of 0.2647, etc. And it wants to the nearest degree, so let's see what we get. Second function tan 0.2647. Oops, I made an error punching that in. Second function tan 0.2647, and we get 14.8 degrees to the nearest degree would be 15 degrees. Okay, so hopefully as you were doing your practice earlier, we clarified any issues that you might have had, and now you can work on the rest of this sheet. There's some practice questions here, 1, 2, 3, 4, 5, 6.